computer, can you see the actual green circuit board, and everything is soldered onto it or connected to it? So just like a mother would hold her children, the motherboard holds all the components that are necessary so that all of those components can link with each other. Yep.
So it holds on those black, you see the black, there's like little holes, like a little gap.
Okay.
Yeah, you put that green one, which is called the RAM, inside.
Correct. And can you see the RAM on this screen?
Yes.
Good. So tell me where the RAM is.
Over here, the right.
Top right. Good. Excellent. So can you remember what RAM stands for?
No.
Okay. It stands for Random Access Memory. Random access memory is temporary memory. So if you are working on the computer and you do some work, so for instance, if you start to put some words in, but you haven't saved it, it's held in RAM memory. So it's held temporarily until you actually save it. But the problem is, if your computer suddenly crashes, all of that data is gone. It's lost. And there's a very special word that we use for that, and that's called volatile. So basically, the RAM, as you say, it slots into the motherboard, and it is temporary memory which holds the data that you are currently using right now. But then, if the computer crashes, all of it is actually lost. Do you know what the top middle image is?
Is it the CPU?
Excellent, that is the CPU. And have you got any understanding of what it means by a quad core?
No.
Okay, so we've got the general CPU, but sometimes people want it to do more processing at the same time, in which case they might have a dual CPU, a dual core CPU, and that would mean it could process twice the amount of instructions as just a regular CPU. Can you guess then what a quad core is?
It makes more data at the same time.
Yes. So if a single core is just one, dual core, it's going to process twice the amount, and then quad core, it's going to process 4 times the amount. Now that actually slots onto the motherboard as well. What is the one bottom left? Do you know what that one is?
No.
Okay, this one is actually a graphics card. Can you see where you would connect the peripheral devices that you might need? So on the side here, can you see the little blue thing?
Yes.
So these are what we call ports, and these ones are so that you can connect the cables. But why do you think somebody might think about changing their graphics card? So they buy a computer with a graphics card. Why do you think some people might think, I think I'll go and buy a new one?
So they can have a better pixel quality.
Yeah, what jobs do you think that they might do that they might need a better graphics card?
It will, but if you have like a bad one that came with the computer, the pixels
Good.
I'm not that very good. And
So anybody who has a job that is to do with graphics. So, for instance, if you're a designer, you would be working more with graphics than you would with words, and graphics take up a lot more memory to store than just words. So, for instance, do you play many computer games?
yes,
Okay, so a lot of people who play computer games buy a better graphics card than the one that was provided with the machine. Again, because they want the graphics of their computer games to be a better quality. Do you know the thing in the middle, bottom middle?
I forgot the name, but it was inside the computer.
Okay, so this is what we call a hard disk drive. And when you save on your computer, have you got a C drive when you save on your computer?
I'm not sure.
You're not sure, okay. But that would be the hard drive inside your computer. So this saves data within your computer. The problem with it is it has moving parts.
Yeah.
And if you actually move your computer, you could actually damage any part of that hard disk drive. But hard disk drives have been around for a long, long time since they've been making computers. So they're quite inexpensive. But now we have something. Have you heard of an SSD drive? Okay, that's a solid state drive. Do you know what size those might be?
They're like little.
Yes, they're quite small. And so rather than moving parts like the hard disk drive has, the solid state drive has no moving parts. It's all saved using memory chip. So that's a good thing, but it also makes it very expensive. So if you go to buy a computer, generally you would have a hard disk drive because it's cheaper to make and cheaper to buy, and most people might want something that was cheaper. But if you actually wanted a more slimline laptop and you were prepared to pay more for it, the chances are you'd have an SSD drive in there these days, because that's what people might actually want. So we call this one in the centre a hard disk drive. So sometimes we call it HDD, and we call the other one, the small one that we were talking about, SSD, solid state drive. But about the bottom right, what is that red thing that you can see there?
I'm not really sure what that is.
No, okay, that's fine. This is what we call a data bus, and it's a funny name to call it a bus. But if you think a bus transports you from one place to another, and that's what these cables do. They transport the data, for instance, from one place to another. Now, this one here is the data bus. We actually have 3 buses. One of them is called the data bus, and that transfers data. One is called an address bus, and the address bus makes sure that it's got the IP address of where the data is going, so that the data bus can send the data to it. Okay. So this is what we've got here. Okay. Okay. Gonna watch a short clip. Okay. I'll turn my mic off as long as you can hear it.
Okay.
Can you hear it?
Hold on. Wait. Something. It's coming from. Wait. It's an error. Send me the link for the video. Okay, thank you. Okay.
Hi, my name is Madison Maxey. I have a company called Lumia, and we focus on making smart fabrics for smart clothing and smart soft good products. The sky's the limit when it comes to textiles.
My name is Danielle Applestone, and I'm CEO of Other Machine Company. We build a desktop milling machine. A milling machine takes a rotating cutting tool and moves it through material to create a 3D object.
Under the hood, all computers do the same 4 basic things. They input information, store and process the information, and then output information. Each of these things is done by a different part of the computer. There are input devices that take input from the outside world and convert it into binary information. There is memory to store this information. There's a central processing unit, or CPU, where all the calculations are done. And finally, there are output devices that take information and convert it into physical output.
Let's talk about input first. Computers can take many different types of input, like the keyboard of a computer, the touchpad of a phone, a camera, a microphone, or a GPS. But even the sensors on a car, a thermostat, or a drone are also different input types. Now let's look at a simple example of how input travels through a computer and becomes output. When you press a key on your keyboard, let's say the letter B, the keyboard converts the letter to a number. That number is sent as binary, 1s and 0s, into the computer. Starting from this number, the CPU calculates how to display the letter B pixel by pixel. The CPU requests step-by-step instructions from memory which tell it how to draw the letter B. The CPU runs these instructions and stores the results as pixels in memory. Finally, this pixel information is sent in binary to the screen. The screen is an output device which converts the binary signals into the tiny lights and colors that make up what you see.
This all happens so quickly it feels instantaneous. But to display each letter, a computer runs thousands of instructions, starting from the moment your finger presses the keyboard.
In that example, the output device was the screen. But there are many different types of output which take a binary signal from the computer and do something in the physical world. For example, a speaker will play sound, and a 3D printer will print an object. Output devices can also control physical motion, like a robotic arm, the motor of a car, or the cutting tool of the milling machine that my company makes. New types of inputs and outputs let computers interact with the world in entirely new ways. This has been helped out by improvements to the speed and size of the memory and CPU. The more complicated a task is, and the more information that's input or output, the more processing power and memory a computer needs. Typing letters on a screen may be easy, but to do complicated 3D graphics or record a high-definition movie, modern computers often have multiple CPUs to process all that information, and many gigabytes of memory to store it.
No matter what it is you want to do with a computer, every single action is about inputting information from the physical world, storing and processing that information, and getting some output back into the physical world.
Okay?
Yes, I've saw. Yeah.
Can you see how important the CPU is in
Yeah.
the computer? And did you hear all the information about input and output that we talked about last week?
Yeah.
Yeah?
So when it says when you press the button on the keyboard.